October. Can someone help me out? What was the total number of students
109.
with spirit during the week?
109.
109. How many did not have spirit?
52.
52. So what is that? 161?
Yeah, 161. How do you know that?
Added them together.
Oh.
20 and 14 makes
34,
33.
32. 30. It should have been 31, 30. Oh my god, it would have been like
Now listen up. What is 32 plus 34 plus 33 plus 32 plus 30 equal?
161.
161. What is 109 plus 52?
161.
So what do we call 161?
Our total.
My grand total. There's a bunch of totals on here. There's only one grand total, right? And what that 161 represents is what?
The total with, the total of students altogether.
That's right. The total students in class all week. Total students in class all week, regardless of whether or not they had spirit. All right? Now, how would I be able to find what percentage of the class throughout the week had spirit? What fraction can I set up to find that? I'll give you a hint. It's number I on the very bottom. Over 161, that's right. What am I going to put over 161?
109.
109. So total number of students with spirit divided by the total number of students in general. What does that give me as a decimal? 0. Point what?
109.
0.68? Okay, rounded, that's fine. What is that as a percentage? 68%. So this is the score that I compared between the three classes to determine who actually won the competition, right? So you guys had 68% spirit score. Now the reason why I did it this way, right? Some people were like, well, why are we doing percentages as opposed to, just how many total people have spirit? Fourth period only had 150 students present throughout the week, right? So by nature of your class size and just overall attendance, you guys would have had an advantage because you had 11 more people that could have gave you 11 more points possible, right? But if we do a frequency, if we turn it into a percentage, we're talking about, what or how frequent people in this class had spirit versus how frequent people in the other class had spirit. Does that kind of make sense what I'm saying? Okay. So it just makes it more fair. You guys, there's 34 kids. My sixth period has 37. So, and fourth period I think also has 34. So because the class sizes are also different, we have to turn it into a percentage to make it comparable, right? Let's see. If I was going to do joint relative frequency of students with spirit on Thursday, how could I set up that fraction? That's G. 32 over 109. Yep. What does that equal to? Wait, 32 over 109. Is that the right denominator? Should be 32 over my grand total, 161. Remember, my denominator is always going to be the grand total unless I'm asked for a conditional frequency. So 32 out of 161, what is that as a percentage? No one has it? About 0.198 or 199. So 19.9%. Give me a thumbs up if that's what you got for G, 19.9%. Just Rhea and Eva. So what did you guys put as the denominator for G? 109? Okay. Interesting. Let's take a look back for a second, just to make sure I'm not wrong. Yeah, so joint relative frequency is one of the middle squares divided by the grand total. Marginal relative frequency, which is what we found in question I, is one of my edge squares divided by the grand total. The only time we don't divide by the grand total is the conditional, which we're not asked about here at all. But if I did want to find, let's just say HIJK, the conditional relative frequency of, let's see, what can we say? So we can say of the students with spirit how many were on Monday? Right, so if I wanted to find the conditional relative frequency of students with spirit, what's the frequency of them on Monday? Then we would take the total number of students with spirit, which was 109. That would be my denominator. And how many students had spirit on Monday, based on the table?
24.
24. 24 divided by 109. Boom, boom, boom. 22. So 22%. Right? If we compared that to the people with spirit on Friday, 13 over 109. 13 divided by 109. That's only 12%. 0.12 or 12%. So we can see when we compare these two frequencies that on Monday, there was a much higher frequency of people with spirit than on Friday. Right? And in terms of the whole week, Friday's spirit only made up 12%, whereas Monday's spirit made up 22% of the week's, spirit participants. All right? Any questions on the front? Okay. How did you guys do on the back? Good? Or not so good? The whole front is wrong. What did you put 109 on the bottom of all of them?
I put 100 on all of them.
You put 100?
I put 109.
Where'd you find 100?
I need to redo it.
That's all right. If you need to redo it, take some time and fix it.
I definitely will, sir.
Okay, sounds good. On the back, we got all the totals, right?
No.
Did we not do this together?
Not quite.
I certainly didn't do this by myself, so we must have done it together, right?
Yes. I'm almost.
Just A through E? Okay. So F says, what's the joint relative frequency of people who purchase a hot dog and a soda? Okay. Just looking at this table, where can I find the number of people that got a hot dog and soda combo?
The total.
Total? Over here? Not quite. That's the total number of people who bought a hot dog.
No, the total with the people. No, never mind.
That's okay. I'm looking for hot dog, soda. See how it says hot dog right here? It says soda right there. I'm going to look where those two intersect. Boom, and that's right here. 57 people got a hot dog and a soda. Right? So if I'm going to find that frequency, I'll put 57 over what?
100.
100? Where are we getting 100 from? What's the grand total? 300. Every single one of these, F through M, all of these should be divided by 300. So take a look at yours. Are all your fractions over 300 for this section? No?
Mine is 100.
I must have done a pretty bad job yesterday explaining this. Sorry.
It's just, we thought it was all 100.
We're just
Maybe we just all slide.
That's okay. Was it because of this example that you guys thought you put it over 100?
Yes.
Yeah.
Yes.
All right.
So we just thought it was 100,
Okay.
It's like too many numbers.
Right. It's
I
too
got
much
you. Too many
calculating,
numbers.
Too
I know.
much
I know it's a
1
lot.
over 0 with the 5 divided by pi and all that type of stuff. That's
Pi?
Yeah, that's nuts.
Okay.
That's how you know she wasn't.
No, it's all. It's okay. Hold on, my wheels are turning.
So that means we could just skip the lesson, right?
Let's see. I'm trying to think of what to do about this, because this is really important. Last year during the SBAC, I was walking around the classroom. At any given point, someone had one of these tables on their screen, which means they're all over the SBAC test. So if we've got to understand how to find these certain things. So I think it might be valuable to take extra time. So.
Are we able to use notes in the next
Oh no. Everything in every room is going to be covered with papers. So all these formulas and stuff you can't look at.
Fail.
You can't use notes. You can't use anything. You can use this.
That's not reliable.
That's not reliable.
Nothing in this.
There's nothing in there. That's not true.
No, for real. Ain't nothing in there except some. If it's like something easy, okay, I might bring back some memories.
Yeah.
If it's something like, I'm gonna be like.
You just got to try your best. Annihilator said, is the SBAC going in the grade book? No. Do you guys know what the SBAC is for?
No.
I forget.
They always tell us and I forget.
Right.
You're not wrong. It is partially for the government. It's
Is it for like is it like on our record so if we get a job they see how smart we are?
no, thankfully not. Jobs are not going to care
I
about
was gonna say
that.
I would not be getting that job.
So the SBAC one is for federal funding. So depending on a school's like overall scores, it determines how much money the government is going to give us for for programs and
so we
stuff
get
like that.
money for this.
The school gets money. So like stuff like like sports uniforms, the garden club, all these types of things come from government money.
Okay.
So if we're underperforming as a school, we don't get as much money. At least I think.
Okay, so basically we making money for y'all.
If you performed poorly and we got more money, then don't you think teachers would encourage you to do bad on the SBAC?
What if everybody fails?
Right, and we don't. We encourage you to do
If we all
good.
fail, ain't nobody getting nothing.
Another thing the SBAC is for, and this is actually more important for you guys, is placement, math placement, English placement.
Oh, they see what to put like
So-
when you go into your next grade. They
Exactly.
See what to put you in.
So next year, you guys listening? Next year you can have 2-term math, or you can have 4-term math, like we have right now.
Oh, I want 2-term.
Which would you rather have?
2-term?
2-term math, right?
Right.
If you're like getting C's, D's, like in this class, and you do poorly on the SBAC, this district's gonna look at that and say, "Oh, this kid clearly needs more time. We're gonna put them in 4-term math, right?" But if you do well in this class, if you've been doing well in this class, and you do decently on the SBAC, they go, "Oh, this person gets it. 2 terms is enough for them."
Okay.
Yeah. Eva. It depends. If you do like really bad on the SBAC, I don't know.
What if you fail the SBAC?
But as long as you're doing well in this class, you should be fine.
That's what I'm saying.
The SBAC is like the deciding factor, where it's like if you're on the fence, like kind of good, kind of bad, they'll look at your SBAC score and that'll determine where they place you. Jawan?
Is there SBAC testing for science?
For science, yeah, but there's no 4-term science, so I don't really know what the science test is for.
It's not honors either.
Yeah, there's no honors science either, so I don't know.
I don't want to be in no type of honors next year. I ain't
That's
that
okay.
smart at all.
You don't have to be. But anyway, the point is, we have to understand these tables, even though it's the end of the year, and I know we're all kind of mentally checking out day by day. There's more and more, more and more people checking out day by day. This stuff is important for the SBAC test. So let me go through this, and let's see if we can kind of get to an understanding. Are you guys comfortable how we got all these totals that are in black here?
That was confusing at first. Yeah, I was like,
Yeah? Okay. So, let me get, hold on.
girl.
All right. You guys see this square right here?
Yes, yes, yes.
57 people that went to the concession stand purchased what? Soda and a hot dog. Right? Is everybody with me? I hear a lot of hooting and hollering. Right, Anila? Okay. Let's see. What does this box represent? Water and hot dog. Every one of these boxes is an intersection of 2 things. This is not just water. It's people who bought water and a hot dog. You guys get what I'm saying?
Yeah.
What about I can't even cover that one up. But this 123. Pizza and a soda, right? Soda, pizza, boom, 123. What about 58? What did those people buy?
Water.
Pizza and a water. So there's 2 food and 2 drink. Everyone that came here got 1 food and 1 drink. Does that make sense? Yeah. So there's 4 possibilities. I could have went and got a pizza and a soda. I could have got a pizza and a water. I could have got a hot dog and a soda. Or I could have got a hot dog and a water. Everybody with me so far?
What if you have a hot dog and a pizza and a soda and water?
That's not one of the options. Let's not complicate it, okay? I'm trying to keep it as simple as possible. So those are these 4 white squares in the middle. These darker squares on the corner, those are my totals, right? So if I just look at 119, 119 people in total purchased a what? Hot dog. Thank you. Hot dog total 119. Now of those 119, half of them got a water, half of them got a soda, but altogether 119 people purchased a hot dog. You guys see that? Okay. 181 people purchased what? Pizza. Yeah, you got it. Good job.
Because pizza's good.
The pizza and total, boom, lines up 181. If I take 123 pizza soda buyers and 58 pizza water buyers, that's 181 pizza buyers in total, regardless of what drink they got. Does that make sense?
Yes.
Okay. And if I go down here, 180 people purchased what? A soda. Soda, total, 180. 120 people purchased what? Water. Water, total, boom, 120. Now, of those water drinkers, half of them bought a hot dog with that water, half of them got a soda. Of these soda drinkers, most of them got pizza, but some of them also got a hot dog. Okay, everybody cool on all that?
Yeah.
Okay. So, 180 people bought a soda, 120 people bought a water. In total, how many people visited the stand? 300. 119 people bought a hot dog, 181 people bought a pizza. Add those up, and how many total people went to the concession stand? 300. If I took all 4 of these white boxes in the middle, 57 plus 62 plus 123 plus 58, that gives me 300. Okay? So these 4 boxes add up to 300. These 2 totals add to 300. And these 2 totals add to 300. But we're not adding all these numbers together. That's what I saw some people doing. I saw some people yesterday with 600 as their grand total. That is not how we find that. Is this making sense a little bit? Is this clearing things up, kind of? Okay. So that's just the numbers. Now we're going to get into the percentages, okay? If I look at F, I want to find the joint relative frequency of people who got a hot dog and a soda. Well, based on these white boxes in the middle, how many people got both a hot dog and a soda? 57. I'm going to divide 57 by my grand total, which is 300. So 300 people went up to the concession stand. Of those 300, 57 of them got a hot dog soda combo. Does that make sense how we set that up? Yeah. Okay, then what is 57 divided by 300? 0.19? Is that right?
I don't know. Let's see.
Yep, 0.19, nice and perfect. So 19%. 19% of the people who visited this concession stand walked out of there with a hot dog in one hand and a soda in the other. Sound good? Okay.
Sounds great.
So now if I want to find the joint relative frequency of people who purchase a hot dog and a water, I'm still going to divide by 300. That's my grand total. How many people ordered that combo of a hot dog with water? 62. So if I do 62 divided by 300, I get 20.7. So 0.207. Which is 20.7%. So these frequencies, these percentages are going to go in these spaces under the table. 19% and 20.7%. Alicia?
Like, you would have round it, like before, like 21%.
We could technically. I'm going to show you why we shouldn't after we get through all these. That's a good question. I'm glad you brought that up. All right.
Oh my god.
You guys okay?
Yeah.
Okay. What about the joint relative frequency of people who bought a pizza and a soda? Well, what's the number of people that got a pizza soda combo? 123. Awesome. Sounds like you guys are following along. 123 over 300. is 0.41. Nice and perfect. That's going to be 41%. So I go over here to H, and that's 41%. Finally, what about pizza water combo? How many people got that? 58. And 58 divided by 300 is 0.193 or 19.3%. All right, so I go up here, 19.3%. Everybody cool on those joint relative frequencies?
Yes.
Okay. What would happen if I added all four of these percentages up? What do you think is going to happen? Right, we should get 100%. 19 plus 20.7 plus 41 plus 19.3. Boom. 100. 100% of the people visited the concession stand. Because we're only looking at people that visited the concession stand, right? So if I'm rounding my decimals, like bumping it up to 21 or bumping it down to 19 or whatever, we might not get a total frequency that is 100, right? So the more precise we can make it, I'm fine with just one decimal place. The more, specific our data is going to be. Because if we were doing the Spirit Week challenge and you guys had 68.9% and the other class had 68.6%, and I just called them both 68 or both 69%, well then it's hard to tell, who actually won. So the more specific we get, the better it is when we're talking about data like this. All right? Any questions I can answer so far? Give me a quick show of thumbs. How much sense is this making? Okay. I appreciate the verbal thumbs up.
Welcome.
If I go to marginal frequency, now I'm not looking in the joint. The joint frequency, those are all tied up in the middle. Where are my margins at on here?
The percentages.
The totals. The
Yeah.
totals, right? My margins are on the edge here. These darker squares on the edge. So I want to find the marginal frequency of people who purchased a hot dog. Does it specify what drink they got?
No.
No. So I don't care about the drink. I just want to know how many people left the stand with a hot dog in their hand. How many people did that? 119. Boom. Total hot dog buyers. Right? 119. What am I going to divide 119 by? 300. 119 divided by 300 is 39.7, 0.397. 39 point. What's that? So like I was just saying, like we want to keep at least one decimal to make it more precise. Technically, it's good enough to say 40%, but I'd like you to be a little bit more precise. It's good for us to be accurate here. How many total people purchased a pizza, regardless of their drink? Right here, pizza total 181. Right? So what's 181 divided by 300? Should give me 61.3%, 0.613. Someone check if that's right real quick. I guess I can. Oh, 60.3. I'm tripping. 60.3%. So based on these frequencies, what's the more popular item at this concession stand? Pizza or hot dogs?
The pizza.
Pizza, right? We had 60.3%, 39.7% on the hot dogs. What about the marginal frequency of people who purchased a soda? How many total people walked out of there with a soda in their hand? Look at the table.
180.
180. Soda total, boom, 180. 180 over 300. Should be like 0.6 or something. Yep, 0.60. 60%. And last but not least, how many total people purchased a water, regardless of what food they got with it?
120.
120. 120 over 300 is 0.40 or 40%.
Man, you really off the top of your head, huh?
Well, when one of these is 60, and I know they're going to add to 100, then the other one obviously has to be 40. Right? In the same way that over here, I had 39.7. I knew it's going to end in a 0.3, and then that would make it 40, and then 60. You know, it's like backwards math. But you could always use a calculator too. That's probably easier. 40%. Right? See how down here now, just like 180 plus 120 gave me 300. What's 60% plus 40%? 100%. 119 and 181 also gave me 300. 39.7 plus 60.3. 39.7 plus 60.3 is also 100%. So that's why I said this whole table is like one big calculator, or like an abacus. Do you guys know what an abacus is?
Oh.
It's one of those counting things where it's like a... I'll show you. You're going to be like, oh, watch.
Oh.
That's what I said.
I grew up on those.
Exactly. I have no idea how they work.
I think I still got mine.
Probably. I don't know how they work, but
Oh,
yeah, in the doctor's office, yeah.
Doctor's office.
So before we had calculators, this was the calculator. Like you used it to count. Again, I'm not sure
I
how.
thought that was like a baby toy.
I mean,
It could
Kind
be,
of.
That
but
wasn't a toy. Was the doctor like twirling?
yeah, that one might be a...
That's the different.
You're talking about this?
yeah, that's the
Okay,
one.
this
That
is
one-
not
that's
anything that
so
has to do with
fun.
counting. This is just
Oh.
for stimulation, I guess. I don't know.
Man, I used to be in that
But it
office.
looks like an abacus.
Similar office.
It looks like an abacus that got put in a blender or something. But
See,
yeah,
they
an
know about
abacus.
the dentist. Look, they got dentists right there.
Yeah, so this is like what calculators were before we had digital calculators. Zach.
Don't ruin it for everybody.
He's about to. What was I saying? So yeah, this whole table is like one big calculator, right? All these middle squares add to the grand total. The sides add up, all the percentages, right? Now, why does this matter? Let's say I work at the concession stand and I'm in charge of ordering food before a football game, and I have all this data.
Right.
What items do you think I should order more of before the next game and have stocked ready to go? What are some popular items that sell? Pizza and soda,
Yeah.
right?
And chips.
A lot of pizza, a lot of sodas. What maybe is a combination that doesn't sell very well here? Either hot dog and water or pizza and water. So if I'm in charge of this concession stand, right, and I see, hey, my pizza water sales are pretty low, what can I do maybe to help increase those sales?
Sell fruit.
Sell
No,
more.
sell them water
Sell more
packet
money.
thingies. Them juice.
Okay,
water
that's
packets.
pretty creative.
You
Inflation.
know, they.
Inflation, I don't think we know what that means, but that's all right.
Just
Kind of the opposite of inflation.
Make it like a combo or something.
Yes, exactly. Make a combo deal. Let's say if a pizza and water is normally like $3, if I say, oh, now it's $2, don't you think this number 58 is going to go up
Oh,
by quite a
yes,
bit?
Yes.
Absolutely.
Yeah, but if you raise the prices, then you get more.
Nowadays, it's actually $5 for
Well,
water and hot dog.
Yeah, I know. It's a lot more expensive than this,
More than
obviously.
that.
If you raise the prices, you're going to get more people that are going to come up and go, ooh, it's too expensive, and then walk away, right?
That's
Yeah, you'll have
really
some
me.
people paying more, but you're going to have some people that are completely turned off by raising prices, right? That's why even at every store, no matter what you sell, the price fluctuation depends on like supply and demand, right? So if a bunch of people want something, they can charge more for it. But if it's something that people don't really want that much of, that's when you see things going on sale. Right? You guys ever been to like Target and looked at like the clothes that's on sale and you're like, this stuff is like ugly. Why is this stuff even here?
Right.
That's why it's on sale. This is ugly. People don't want to buy it. They're like, we got to get rid of it for cheap, $7 for a sweater or whatever. You know what I mean? That's why stuff goes on sale. Or it's, you know, older product that they're just trying to get rid of. But again, it's old because it didn't sell. All right. When you see, you go to like, you know, grocery store, Walmart, you see like bread that's on sale. Why is the bread on sale?
Because it's
'Cause it's
either-
old.
It's either old, moldy, or something like. They be doing
Well-
that with the milk. They put all the old milk in the front and putting the good milk in the back. They be doing that.
Exactly. Because they're trying to sell the product that's going to go bad first. You can't put milk on sale. If anyone's buying milk on sale, that's
something's
a problem.
wrong.
There's something wrong with you, okay? Because I would not suggest you buy anything like dairy product that's on sale, okay?
You gonna find
But-
some bug in your food.
Exactly. Again, so this is why this kind of thing matters, right? For the Spirit Week, yeah, we do it so that we keep it fair and we can see who technically has the most spirit as a whole class, right? But if I'm looking at something like this and I'm in charge of the concession stand, I know, hey, the next game this week, I got to make sure we got a bunch of soda on deck because we're going to run out, right? Clearly, soda's a lot more popular than water. Pizza is way more popular than hot dogs. So I got to order more pizza to keep up with the demand, right? More supply for more demand. Maybe I can put the hot dogs on sale to kind of boost, the sales of those and get rid of some of this product. All right, just a little real life application of this. Does that kind of make sense? Yeah.